Standard 8 is geological hazards. What's funny because we're studying that in 8th grade now. That's our last unit, so you guys are going to get it again in 8th grade. Hopefully you'll learn things in addition to what you've learned this year. But one thing we need to remember is that wherever you're going to build your house, wherever we're going to build skyscrapers or any type of building, we need to take the geological hazards into consideration. What things are going to be our constraints for building that building there. And if we're building on the coastline, and here's our beach area, and here's our water, here's the ocean, then we need to remember what constraints we would have if we want to build a nice hotel there or some beachfront property, a beach cabin, something like that. What would we need to take into consideration? And we know that if you're along the coast, one thing that the hazards that are to living on the coast are like hurricanes or tsunamis. Sorry, it's so hard to talk and write at the same time. Tsunamis. And then there's lots of natural hazards like that are there because of the geology of the area. So if you have these things here, you need to make sure you're building a structure that can withstand things like high winds and floods. So you all remember our stilt houses. So if we're going to build on near the ocean, we want to build like stilt houses and make sure that those stilts go deep into the earth. And these are really, they're strong. And that's going to protect our property from these natural hazards when they come. We also know about earthquakes. We spent some time talking about what we do in order to reinforce the existing buildings that we have. Some of the historical buildings that we have, we don't want to destroy them. We don't want to pull down the historical architecture because we value that as a society. So instead of replacing all buildings with, steel beams or, other kinds of materials that can withstand earthquakes better, materials that are both strong and flexible. In order to do that, we retrofit buildings or renovate them and add things like braces to their existing walls. So if we had a wall here, we wanted to reinforce it to make it earthquake proof, we might add some braces in there. So some steel members here to make the structure more stronger and able to be supported if an earthquake comes. Now I'm just going to explain the physics of that when energy passes through a medium, then it will transfer to other mediums. And so when earthquake movement passes through the earth is the medium, and it travels in waves. And so it's going to be transferred to the houses that are built on it, unless we somehow can redirect that energy so that it doesn't go into the building. It redirects away from the building, away from where it could do damage. And that's why we talked about the base isolation system. I think we basically represented it like this. We had a building that sits on top of these risers that can move, especially horizontally in an earthquake. So it's redirecting its energy to the sides, and instead of straight to the house. And so that's our base isolation system. And And I think that's all we need to remember for this standard, especially the braces. And I don't know if I have a question about the base isolation system, but that was just so cool. I love to talk about it again. So just remember that unit.